Coffee cup calorimeter. Objective: to study construction and working of a coffee cup calorimeter and to calculate heat of neutralization. A device used to measure changes in thermal energy under constant pressure is called a coffee cup or polystyrene calorimeter. It is made up of two polystyrene styrofoam cups nested to form an insulating system. It prevents the energy from flowing in or out of the system. Since this calorimeter works on constant atmospheric pressure, it is also called constant pressure calorimeter. Coffee cup calorimeter is mainly used to determine changes in thermal energy during processes such as dissolving, heating, cooling, and neutralization. Neutralization is an exothermic process during which an acid and a base react to form salt and water. Pour 90 milliliters of 1 mole per liter sodium hydroxide in a coffee cup. Initial temperature of base, such as 90 milliliters of 1 mole per liter sodium hydroxide, is noted as 23.5 degrees centigrade. Add acid, such as 10 milliliters of 2.5 mole per liter sulfuric acid, and switch on the magnetic stirrer. Here, sulfuric acid and sodium hydroxide react to produce sodium sulfate, water, and some amount of energy in the form of heat. This released energy is absorbed by water molecules as its specific heat capacity is very high. This raises the temperature of the solution. Note down the temperature when it becomes steady. T2 is 30.1 degrees centigrade. Rise in temperature, delta T, is equal to T2 minus T1. Thus, delta T is equal to 6.6 degrees centigrade. Rise in temperature indicates that some amount of energy is released during the reaction. On the contrary, decrease in temperature during any reaction indicates that some amount of energy is absorbed. Calculation of heat of neutralization. Heat of neutralization is the amount of heat evolved when one equivalent of acid is neutralized by one equivalent of base. Let us first calculate the moles of both the reactants. Moles of NaOH is equal to volume into molarity into stoichiometric coefficient. Since NaOH is monoacidic, its stoichiometric coefficient is 1. Moles of NaOH are found to be 0.09 mole. Since sulfuric acid is dibasic, its stoichiometric coefficient is 2. Hence, the moles of sulfuric acid will be 0.05. The moles of H2SO4 are lower than that of NaOH. Hence, H2SO4 is a limiting reactant. Total volume of reactants is 90 milliliters plus 10 milliliters. That is equal to 100 milliliters. Hence, mass of reaction mixture M is equal to 100 grams. Assuming the density of reaction mixture is 1 gram per milliliter, delta T is 6.6 degrees centigrade. C is the specific heat capacity of water, that is 4.2 joule per gram degree centigrade. Here, assume that the specific heat capacity of water and the reaction mixture is the same. We can calculate heat of neutralization or enthalpy change of this reaction, delta H, using the formula M into C into delta T upon moles of limiting reactant. Substituting all the values in the given formula, the value of delta is found to be 55.44 kilojoule per mole. Summary: we have learned that a coffee cup calorimeter is a constant pressure calorimeter. We have also studied how heat of neutralization can be calculated using coffee cup calorimeter.